This demonstration is going to show two methods of applying special ditch profiles to control the flow of water. The first is going to utilize point controls and is a very easy process. In this example, I want the right ditch starting at station 360 plus 00 elevation of 513 to flow up station minus 1.5% for 300 feet. I really don't need to utilize a profile to do that. I can simply do that with point controls. To start, I would select my corridor, go over to my corridor tools, and choose to create a point control. And the first thing I do is I give it a station range, so we're going to be from 360 to 363. We're going to give it a description, right ditch flow line, and then we tell it what point we want to control. I can simply pick that right here in my dynamic cross-section view if I want to. So as I hover over that, it'll populate that. And then we tell it what we want to control. Well, we need to control it vertically. And on the vertical option, we want elevation and grade. So we choose that. Our starting elevation is 513. Our downgrade is minus 1.5. So we'll enter and accept that and allow that then to process. And you'll see now we have in our cross-section a point control applied. And so as we go down through our project, we're going to be honoring that point control from 360 to 363, taking us through that minus 1.5% grade down to the ending. And so there's our last station in the range. And when we come to our next station in our model, you'll see that we no longer are controlling that ditch elevation. So that's one way that we can control the slope of a ditch, is through the use of point controls. In this next example, I want to control that right ditch, but this time by using a special ditch profile. So in my geometry file, I've opened up the profile model of that particular baseline, and I've added a new profile in here. And if I select that profile, in the context sensitive quick properties, I'll see that I've given it a name called RT Ditch. It's important that you name it, and then that will send that back to coordinate geometry also, because it's using a feature that auto exports. So let's go ahead and jump back over to our corridor now and utilize that profile. So in our corridor file, we want to select our corridor and go to our corridor tools. And we want to create a point control again, but it's going to be just a little bit different this time. We're going to start at station 360, and I'm going to stop. By hitting my N key, I can unlock, and I want to go to 370, and so we'll accept that. Right ditch flow line. And the point we want to control, I can just hover over to my dynamic cross-section window and accept that. And we want to do vertical, linear geometry, and now we're going to pick our main geometry baseline, and it then asks us either to accept the active profile proposed, or I'm going to come over here in my profile element and pick right ditch and use that one instead. And then our vertical offset is going to be 0 for our start and stop, and then we'll allow that to process. Now, I don't know if you caught or not, but when it processed, it actually set the elevation properly, but it modified the slope instead of the horizontal offset. If you wanted to maintain the slope, and I can just show you that here by right-clicking and placing a temporary dimension line. So let's go from the edge of pavement to the flow line of the ditch, and you can see that we have an odd slope there. So how do we fix that? If we want to maintain that 4:1 slope, what do we do? I'm going to go edit that template drop. So we'll select our template drop, edit, and on this right side, I'm going to edit this ditch flow line point. Because we have given it a profile, it has to override a vertical component. Well, the only one of these constraints that has a vertical component is the slope, so therefore that is what has to be overridden. If you would rather modify the offset, this is the little trick. What we're going to do is we're going to change this just a minute to vertical, and we're going to change this to slope. Now both of these constraints have a vertical component, and so it's going to pick that first constraint and override it, therefore adjusting the offset from the edge of pavement. And so when we apply that change, and then we say OK, now watch what happens to our cross section. See, now we have maintained our 25% or 4:1 slope and adjusted our depth accordingly to the proposed profile. And so that's just a little trick that may help you in the design process. But that profile now is being followed on that flow line of that ditch as expected.